What if objects start to sense and communicate? What if all objects are interconnected? What if we have an Internet of Things? Life becomes easier, right? Welcome to the future. Good day, my friend. We are Group 23. We are here to show you a screencast on the topic Data in Internet of Things. First, let me go through the agenda for you. First, we give you an introduction about the Internet of Things. Then, we explain the data involved in IoT. Then, the major prospects in the field of IoT, the problems and challenges involved in this field, and the solutions as well. In the end, we conclude with our findings and then we provide our references for the screencast as well. So, what is the Internet of Things? The standard definition is the Internet of Things is the network of physical objects or things embedded with electronics, software, sensors, and network connectivity which enables these objects to collect and exchange data. In short, it is any device with a sensor attached to it called a thing. That sensor can communicate data to a cloud or storage through the internet to analyze and make meaningful decisions. This setup as a whole is called the Internet of Things. So what is a big data? Big data and IoT are two sides of the same coin. Bill Smaro, CTO of Dell, famously called the Dean of Big Data, quotes that big data is analyzing large amounts of mostly human-generated data to support longer duration use cases such as maintenance and protection. Now, how big is this data we are talking about? To get a clear idea, let's see a common man's social life. Every minute we send 204 million emails, generate 1.8 million Facebook likes, send 278,000 tweets, and upload 200,000 photos to Facebook. Woo! Isn't that huge? All these are raw data. However, the critical challenge is using this data when it is still in motion and extracting valuable information from it. This valuable information could be lifesavers as well. We as a team decided to focus on two major prospects of IoT in this technologically driven society. One is smart cities and the other is medical field. So what is the problem and what is the need for a smart city? 50% of the world's population is in cities. Nearly 70% of the world's population is projected to live in cities by 2050. Cities will face various challenges from sustainability and energy usage. We need one central solution. And what is it? It is the smart city. A smart city is an urban area that collects different types of electronic data from sensors. This data is used to manage assets and resources efficiently. Some of the examples of smart applications in a smart city are smart parking, smart lighting, waste management, infrastructure access, traffic congestion, health and safety. In each of these sectors, the sensors collect the data and this information is used for the betterment of the society. For example, data on traffic congestion can help people avoid traffic in certain routes during the peak hours. However, there are several challenges in the data obtained in a smart city. Data heterogeneity. To translate physical, biological, or social data into meaningful electrical signal or data is a challenge. The other one is decision making under uncertainty. The boundary conditions of these devices should be specified with sufficient accuracy, or else the consequences could be catastrophic. Cybersecurity and privacy of data. In case of privacy, the data from individuals have to be protected. Privacy is one of the key issues in IoT and we will look into it with some of the solutions which can be used to address this issue. First, let us see what types of data are available. There are four main classes as you can see in this picture. First, the personal data which is used for service purposes. For example, personal data related to the city and its inhabitants are in this quadrant. The next one is personal data used for surveillance purposes. It involves data for police, from minor violations to criminal offenses, comes under this category. The other one is impersonal data used for surveillance purposes. This quadrant cannot be linked to a single person since the data is not personal. The monitoring of traffic flows, public transport, crowd, sports events fall in this category. The last one is impersonal data collected for service purposes. A big chunk of the current smart city technologies use this data collected for the benefit of the city environment. For example, monitoring systems for air, noise and water. Some ways in which the privacy concerns can be addressed are discussed here. Firstly, we need to identify which privacy concerns for the citizens are at stake with specific technologies. Then, develop a specific city policy on new developments that accommodates the concerns of the citizens. With respect to privacy, we can adopt several techniques. Some of the techniques to secure data are discussed here. One is the onion routing. It encrypts and mixes the internet traffic from many different sources. That is, data is actually wrapped into multiple encryption layers, thereby keeping the data from each person secure. The DNS security extension makes use of public key cryptography to sign resources in order to guarantee authenticity of the data. With these techniques, the data obtained from the sensors are safe and secure. I am sure that in the coming years, smart cities will play a huge role in the development of a country. Now my teammate Zawi would explain the other use case.
Hi, I'm Javi and I'm going to discuss in a way how could we take advantage of IoT and big data in what healthcare refers. As we will see, the applications and improvements are multiple. So to start with, let me first introduce some of the current problems that we are facing nowadays to better understand the needs. This slide depicts a real situation in a region of Zambia, and in it we see a doctor that goes home by home asking whether the children have been vaccinated or not, and keeps record of that. Naturally, that takes a lot of time and effort, and to end up with, piles of papers, which then have to be digitalized, and most probably information will be lost at some point. Okay, whilst this being an extreme case of lack of efficiency, I am sure that we have experienced at some point taking a wrong drug or being wrongly diagnosed, but wouldn't it be awesome to get somehow profit of these errors for the future when encountered with a similar situation? In most cases, most probably, some kind of relation exists between those patients that lead to a bad assessment. And for that reason, let's briefly see some of the fields in healthcare where IoT and the use of data could improve. Electronic health records, that's a record of a patient's medical details in digital format. Real-time alerting, that is achieved by means of an IoT wearable, for instance, which monitors some of our vital constants, and we can react instantly. Predictive analysis or analytics, using the collected data to research and predict diseases based on data we produce. The same way we can predict weather, for example, we could predict diseases, as at the end of the day is a matter of interpreting inputs and improve in each iteration. Using health data for informed strategic planning as well, for example, to better allocate staff in a hospital. Big data could help using cancer or any other disease, as the more data we have, the better we can study the current diseases. Then in telemedicine, how many times have we felt bad and gone to see a doctor and the only inputs he or she needed were something like, where does it hurt you, is the pain persistent, so for sure in many cases it should not be needed to attend a hospital for that. By means of sensor we could give better and measurable facts. Also, I don't know how it works in your country, but at least in mine, and I'm sure that in many as well, sometimes we have to wait for really long in public hospitals when going through emergency requests, because as currently one of the major hurdles to overcome in identifying high-risk patients is the lack of data. So the drive now is to understand as much as possible about patients and as early in their life as possible, hopefully picking up warnings, signs of serious illness at an early stage. That treatment is far more simple and also less expensive. Of course, this is not completely new because that data was already gathered in the past, such as with pedometers, for example. But now with the rise of IoT, this data can not only be used for ourselves, but for medical records and to be used as doctors as well. Okay, so now that the benefits of IoT and big data have been discussed and are quite clear, let's see the other side of the coin and the issues which are out there as well. Mainly, I would say that it all boils down to privacy. We have to bear in mind that healthcare data is very sensitive and organizations have to be very careful about security, and not only that, but comply with federal regulations as well. So information of a patient should be released to others only when the patient's permissions or by the legal representative are just when allowed by law. It's interesting that with only the zip code, gender and date of birth, in almost 90% of the cases we are uniquely identified. So there is no need even for name or personal ID for privacy vulnerability. But it's not just that. Data can be linked. So for instance, once we catch one's user through his medical records, we might also be able to link this info with a voting list or even bank records, which supposes a bigger problem. But still, privacy is highly contextual. Because for instance, what patients' expectations of privacy changes when disclosing information to a care provider versus a random person on the street. So for that reason, and in order to deal with those privacy and anonymity issues, what we propose is to actually give the rights and decision power to the end customer. First of all, by letting every patient decide what information he or she is willing to share for research purposes. This suggestion is based on the idea that, first of all, and as I have already mentioned, each patient will have a different boundary of what he or she considers private. And secondly, as happens with other cases, the fact of being you, the one who is in control of what to share, adds transparency and trustworthiness. Naturally, there would be cases in which patients just don't want to share anything at all, but in those cases, well, don't they have the right to? And in fact, in some cases, that approach might actually be more positive, because by cutting down and predefining what information could not be shared, we are taking a pessimistic approach, assuming that certain data will not want to be shared by patients. But what if someone does not care at all and wants to share more data than we initially assumed? So therefore, what we think is that whilst in some cases we might get fewer data than we would like to, in other cases it could be more as well. So of course, sharing data wouldn't need to forcefully mean violating our own privacy and be exposed to everything I mentioned before. So here comes our second suggestion. Instead of directly sharing, let's say, age and city where we live, all the data could be encrypted in such a way that a potential third party accessing the data would not be able to understand it. So the result would be something like what we see here. Instead of having a database with tables like this, on the left, that's what we would have. Obviously, the company or institute research, in that case, who the data is addressed to, would have the key to decrypt this information, so for them it would be legible. So encryption is extremely important when everything is interconnected, such as is the case with IoT and big data. And how could this be done? Well, what we propose is a similar approach to blockchain. One idea could be that the user could have a unique password, which would not be stored in any third-party database, but instead the patient would be the only one having it, and that could be used to prove that the user is the one who consents forwarding this data in each flow of the information. In that way, we would be sure that the data is not leaked to anyone else who we have unauthorized. And how this works is that given a password with a mathematical function based on multiplication of prime numbers, it is very easy to corroborate that this password belongs to a certain user, but not the other way around. What that means is that it is close to impossible to find the password by just having the user's hashed ID. This makes the approach very secure and reliable. So as we have seen, big data and IoT are already nowadays converging to bring us a wide range of benefits to our daily lives in many fields. Nowadays, 2.5 exabytes are estimated to be daily generated, and even though today we only have the means to store around 5 billion gigabytes, the technological growth makes us think that we will be able to manage that, or at least a great part of that. So, if resources are there available, well, why don't make use of them? Even data items that could seemingly not have anything in common, and we in our daily lives would most probably never correlate, might actually have some relation, and that is what big data and deep learning could make use of for research purposes. For instance, by gathering very huge amounts of data, we may find out that some correlation between people who eat a certain food quite often and some kind of cancer are there, but now without the use of big data, this would be quite difficult for us to spot. So in general, and summing up, the more information we have, the better decisions we can make. And the good news is that we already count on the required technology to do so. So we have to take into account as well that given that these are in a way still emerging technologies, so sometimes there can be a bit of a lack of expertise. So every new technology needs some time to get more robust and to settle down. But in our opinion, the current frontier which we are experiencing, apart from the privacy and security matters as we have already discussed, is also, such as happens with the driverless cars, for example, everything that surrounds new things. I'm of course talking about regulations and also, very important, people's mindset and willingness to adapt and to adopt new things. As the discussion out there is always, well, who to blame whenever an accident occurs, but what we should see is the big picture and evaluate the benefits and improvement. Obviously there will be issues which we will have to overcome, but sometimes we forget that there are issues in our current approaches as well, and the discussion should be more focused on the comparison and the improvement, which objective facts lead to think that it would be huge. So with the benefits of machine learning and deep learning, we could potentially have a technology which only gets better and better and really learns from mistakes, not as humans. So well, that has been all from our side. We hope you liked it and found it interesting, and thanks for listening. And finally, here we have the main references that we use or that we found interesting in case you would like to dig deeper into these topics.